Now we're going to look at graphing linear inequalities. Here's our first example. Graph 2x minus 4y is greater than or equal to 8. Step 1. Replace the inequality symbol by equals and graph the linear equation. So we're going to have 2x minus 4y equals 8. Now one thing to note is that we are allowing the equation to be part of the solution because it says greater than or equal to. So let's keep that in mind as we're graphing. So let's move over to a graph now. And we're going to look at our equation. 2x minus 4y equals 8. Let's just use our intercept method to graph this. If we let x equal 0, then we can see that in the equation 2 times x would be 0, and we're solving negative 4y equals 8 to give us negative 2. If we let y equal 0, then the term that has y in it would be eliminated, and we have 2x equals 8 to give us a value of 4 for x. Let's plot those 2 points. We're going to have 0, negative 2 plotted along the y-axis, and 4, 0 plotted along the x-axis. We're now going to graph that straight line. Let's look at now step 2. Choose a test point from one of the half planes and not on the line. Substitute its coordinates into the inequality. Well, let's see what that means. We have actually divided our plane into two what are called half planes. There's a section that's above the line and there's a section that's below the line. What this instruction tells us is to choose a point that we are sure is not on the line. The origin is always a nice point to choose. It's pretty obvious where it's located. As long as the origin is not on the line, we can use it. So we're going to test the origin, which has coordinates 0, 0. To do that, we take our value for x and make it 0, and our value for y and make it 0 in the original inequality. So we'll have 2 times 0 minus 4 times 0 greater than or equal to 8. Now let's evaluate. 2 times 0 is 0, minus 4 times 0 is also 0, so we end up with 0 greater than or equal to 8. Well, this is not a true statement. In fact, it is a false statement. Let's see how to interpret this. If a true statement results, we would shade in the half plane that contains the test point. So what do we see logically must happen since it is false? That means we're going to shade in the half plane that does not include the test point. Since the origin did not make our inequality true, we shade in the half plane that ends up being below the line on the graph. Now here's another linear inequality problem. Graph y is greater than negative 3/4 x. We begin by looking at the equation y equals negative 3/4 x. This is going to give us a border between two half planes. We can graph this using the slope-intercept format. We notice that the y-intercept is going to be 0. Let's plot that point. It's right on our origin. We then use the fact that our slope is equal to rise over run. We'll move from that point 3 down, pulling that negative sign into the numerator, and our rise would be negative 3. 1, 2, 3. And then we'll run a 4. 1, 2, 3, 4, and we'll plot that second point. Now before we draw in the line, let's notice that even though the line will be the border between two half planes, in this case we have what's called a strict inequality, meaning that we do not end up including that border as part of our solution set. We can indicate that on the graph by drawing it in as a dashed line. Now we have two half planes that we have to decide which of the two half planes is going to be shaded in. We have to choose a test point. In this example, the origin is not a good point to choose since it lies on the border. So let's choose another point and make sure we're sure of its coordinates. So for instance, let's choose the point right here on the x-axis with coordinates 4, 0. I'm going to take that point and we're going to test it in our original inequality. That means I'm going to substitute the value of 0 for y. We're going to write down the inequality. We're trying to find out whether that's greater than negative 3/4 multiplied times the x value, which is 4. Simplifying, we have 0 is greater than, multiplying here gives us negative 3. 0 is greater than negative 3, so this is a true statement. What that indicates to us is that we need to shade in the half plane that includes the point that made the statement true. So that means we're going to include this section of the graph, which is above that line. By the way, notice that in the original line, it now says y is greater than this expression, and we think of greater than as meaning above, and since it's solved for y, that helps us to see that we have shaded in the correct region. Now let's look at two more linear inequalities that we need to graph. Let's graph each inequality in the rectangular coordinate system. Our first one is the inequality y is greater than 1. Now, even though there's a single variable here, we're told that we're working in the rectangular coordinate system. So that means that when we look at our equation, y equals 1, we want to recognize that as the horizontal line that we can graph 1 unit above the x-axis all the way across. Here's the value of 1. Notice that even though it's the border, we don't want to include that straight line in our solution, so we're going to graph it in as a dashed line. Now, we can see that in this case, we're looking for y values that are greater than 1. All of those points that would fit that description need to be in our solution. So instead of using a test point, we can simply see the y's bigger than 1 would have to be above that line. We shade in that section. Let's move to part B. We have x less than or equal to negative 2. We're going to begin with our xy plane. Let's look at our border, which would be the equation x equals negative 2. We want to recognize that as the vertical line where all of the x coordinates are going to be 2 units to the left of the y-axis. This time when we graph this in, let's just notice that we want to include the border since we have x less than or equal to negative 2. So we're going to draw that in as a solid line. Let's again at our x value of negative 2. Now we want the x values to be less than or equal to negative 2. We've already taken care of the or equal to portion. To be less than negative 2 requires us to be moving further to the left, and so we're going to shade in the half plane that lies to the left of our border. The next problem is going to give us a circumstance where we're using inequalities. Here it is. Show that point B in the following graph is a solution of the system of inequalities that describes healthy weight. Well, let's start off by figuring out what the coordinates are for point B. Here, our point B is located at the intersection of a vertical line where the x value is 66 and a y value here of 130. Here's the system of inequalities that describes that region. We're going to take our x value of 66 and our y value of 130, substitute them into each of the inequalities, and see whether that gives us true statements. So we'll have 4.9 multiplied times 66 minus 130, and we're checking to see whether or not that is going to be greater than 165. And then we're going to have 3.7 times 66 minus 130, and we're checking to see whether or not that value is less than or equal to 125. Using our calculators, we can come up with 4.9 times 66 minus 130 as the value 193.4, and that gives us a true statement. In our calculators, 3.7 multiplied times 66 minus 130 gives us 114.2. And that value is less than 125, so we can see that the point that we were looking at does fit the criteria as given. Now let's look at a problem where we have to graph a system of linear inequalities. We want to graph the solution set of the system. Our first inequality is x plus 2y is greater than 4. Our second inequality is 2x minus 3y is less than or equal to negative 6. We're going to start by graphing the first inequality. We'll begin with a border, which is going to be the equation x plus 2y equals 4. We can use the intercept method in order to find 2 points on that line. If x is equal to 0, then we're solving the equation 2y equals 4, and y would have to equal 2. If y is equal to 0, then we're solving the equation x equals 4. Now there's not much to solve. We get x equals 4. So let's start by plotting those 2 points and graphing that inequality. Let's make some marks. We have 1, 2, 3, 4. We can plot our y-intercept. We have 1, 2. We can plot our y-intercept. Here's our x-intercept and our y-intercept. Let's connect the dots. Now, pay attention to the fact that as we're connecting the dots, we don't want to include that border because of the fact that we have a strict inequality. So therefore, when we draw this in, we're going to do so with a dashed line. Next, we need to decide which half plane we should shade in, and we can do that by choosing a test point. We see that the origin is obviously on one side of that line, so we can test that point in our inequality. We're going to go back and substitute for x and for y. We'll have 0 plus 2 times 0 is greater than 4. 0 greater than 4, we notice, is a false statement. And what that indicates is that we should shade in the part of the plane, the entire plane, that is the half plane, that does not include the origin. So we're going to shade above this line. Now let's move to the second inequality. We have 2x minus 3y less than or equal to negative 6. Let's start with the equation 2x minus 3y equals negative 6. Again, we'll use the intercept method. If x is equal to 0, we're looking at the equation 2 times 0, which would be 0, minus 3y equals negative 6. Our y value would have to equal 2. If y is equal to 0, we're looking at 2 times x minus 0 equals negative 6. Our x value would have to equal negative 3. Let's plot those 2 points. We have 0, 2, and notice it happens to be the same point. And then we have the point negative 3, 0, which we'll plot as our x-intercept. And now we're going to graph this line. When we graph this line, notice that we're going to have the border included in our solution. So we'll draw that in as a solid line. Now when you're doing this, using different colored pens is going to be nice because you can keep track of your different solution sets as you're working with it. We need to now complete this inequality by finding a test point and plugging it into the original inequality. We can again test the origin, which is pretty obviously below the line. So if we test the point 0, 0, we're going to be substituting 2 times 0 minus 3 times 0 less than or equal to negative 6. This gives us 0 less than or equal to negative 6, which is also a false statement. What that tells us is that we do not want to include the origin in our solution set. So again, we're going to be shading in the half plane that does not include the test point. This again happens to be the section that is above the line. And now it comes down to trying to decide what the solution set would be. In order to come up with the solution set, we would need both of these inequalities to hold simultaneously. And that would require us then to be looking at the section where we have both the green and the orange at the same time. The border would be the solid green line in this section in the first quadrant and the dashed orange line in this section in the second quadrant, and then everything above those 2 lines. We're going to now look at how to solve a system of inequalities. We want to look at what the graph is. Graph the solution set of the system. X is less than 3, y is greater than or equal to negative 1. We'll begin by looking at the graph of x less than 3. We start by looking at the border, which would be the equation x equals 3. Now x equals 3 gives us a vertical line. Because we do not allow x to actually equal 3, we're going to graph this vertical line using dashes. Next, we need to see that the vertical line divides the plane into two half planes. There's the section to the left of the vertical line and the section to the right. To determine which side we shade in, we're going to look back at the inequality. We see that x should be smaller than 3, so therefore we want to shade in to the left, as that would give us all x values less than 3. So we're just going to shade in this half plane, which is to the left of the dashed line. Now we're going to turn our attention to the second inequality. We have y is greater than or equal to negative 1. Likewise, we're going to begin by looking at the border, which would be the line y equals negative 1. That's a horizontal line. We can graph it using a solid line because of the fact that we allow y to equal negative 1. Draw this line going across. And at this point, what we're doing is disregarding what we have in already shaded and just concentrating on our new inequality. We notice that we want y to be greater than or equal to negative 1. Well, y values are greater than negative 1 if we shade the portion of the plane that is above that horizontal line. So we're going to shade now above the horizontal line, going all the way across. Now, because we want the solution set, that is, we want our x values to be smaller than 3 and we want our y values to be greater than or equal to negative 1, we notice that our actual solution is going to be the portion that is shaded in both colors in this case. So I'm just going to shade that in a little bit darker here. Let's just go ahead and notice that the portion that is actually the solution set is in this region. Now, one thing to consider is whether or not, where we have our two lines intersecting, we're going to include this intersection point. Well, notice that at this point, the x value would equal 3. This is the point 3, negative 1. We do not want to include that point, so we're going to emphasize that by putting an open circle here, indicating that that particular point is left out of the solution set.